Thank you. Yes, I'll be presenting Indium Bump Interconnect for micro-LED displays. Here's the agenda, so just a quick touch on Finetech and then what we do with the Indium Bump Interconnect and its challenges. So Finetech, we're a die bonding, die packaging, rework solutions OEM system manufacturer in Germany. We also sell technology and application development, so process and application development for whatever you might be working on. Indium Bump is not the only thing we do. And yeah, we're headquartered in Berlin and we have site sales, application and process development worldwide. So just get in touch and you can find your local office anywhere. So today, MicroLED Connect, here we have a GaN-on-GaN daisy chain green monochromatic display. Yeah, so we're going to go over some topics like AR, VR, quantum processes, and focal plane arrays, just as a trend for what Indium Bump Interconnect is looking at. Yeah, a quick statement: bump size is from 5 to 10 microns generally as the standard trend, and they're going down to about 2.5 microns. We're seeing this on the market coming more and more, and if you have some questions, you can go to Intel VAC after this or Novel Tech. Yeah. This display is into the 600,000 something bumps on the display, and it's 8 by 10 millimeters wide. Yeah, chip to wafer, chip to substrate. That's the technologies that we're focusing on, and we'll see that here. So the focus and the trend that we're seeing in the micro-LED display market is that as the displays are getting smaller to get into glasses and to get into all these kind of AR, VR applications, the pixel density is dramatically increasing, which just means your interconnect is getting smaller, tighter pitch, your accuracy is going higher. For quantum qubit, superconducting qubits, we see that they can't change the format of a qubit, so the only way to grow is to expand horizontally or vertically. This also comes with its own challenges in another presentation altogether. And for IR thermal imaging, we're seeing that it's going from chip on substrate to chip on wafer, and Sony is also developing a copper wafer level bonding. So this will completely disappear from the market at some point. And this will also probably be impacting AR, VR, micro-LED displays one day in the future. Indium Bump Interconnect. Sorry. Here we have a thermal imaging display as an example. So the pros of indium, it has very low melting temperature. You can vacuum deposit it at a very small interconnect, a very small pitch, a very small size. It can be bonded using cold compression, thermal compression, and reflow bonding. Yeah, the cold compression allows for very good performance in cryogenic applications like space and superconducting. I don't know who's going to be wearing AR glasses in space, but it is a benefit. And yeah, the ductile properties of the metal allow for very good CTE mismatch from GaN and silicon and so on. And it retains a very high electrical mechanical performance when it is at very cold temperatures and superconducting. The cons, it oxidizes and it's extremely sensitive to work with and easily damaged. So handling and packaging, this is one of the main things you have to focus on as a production capacity. So at Finetech, we focus on two processes. We have cold compression bonding. This is just great alignment, high flatness, high force, push it together, and it's like a hot cookie breaking and touching the inside gooey bit, and it bonds. And then reflow bonding, where we push formic acid through the gap, we reduce all of the oxide, and then we touch it together, and you get the purest, cleanest indium bond interconnect. So this is generally what it looks like in an IR thermal imaging sensor or a micro-LED display. You have your pixels or your sensor, your GaN chip, and then your ROIC or your driver. The main challenges of bonding these is number one, accuracy. You're aligning very tiny bumps or pads to very tiny bumps or pads. And they're very short, so as wide as they are tall. So if you have at polar light 1 micron bumps, they're only 1 micron tall. So accuracy is also a vertical, like a Z-axis requirement as well. Flatness and copolarity, as mentioned. Generally, you coat your materials in photoresist for shipment, for storage, for handling, this kind of thing. So being able to clean and prepare materials from photoresist is also a challenge that you'll have to face. And yeah, sensitive handling. You can damage this stuff